Boys and girls, in today's video, we are going to be comparing fractions using fraction benchmarks. So when we say fraction benchmarks, we are thinking about comparing fractions and thinking of them as close to 0 or close to 1/2 or even close to 1/2. Now there are going to be times when fractions may be larger than 1/2. Okay, and we can think about, oh man, well that fraction is greater than 1/2, while another fraction would be really close to 1/2. And because the other one is greater than 1/2, then that fraction would be larger. So this is just one of those times when we're using our understanding to really compare fractions. And when we say benchmarks, we're thinking of comparing it to 0, 1/2, or 1/2. Okay, so in my image here, you can see fractions that are equivalent to 1/2. I'm just drawing a vertical line at 1/2, and I can see 3/6 is the same thing as 1/2. I also see 2/4 is the same thing as 1/2. Okay, and so what's going to happen if we have not already seen that? If our denominator is an even number, okay, like 2, it ends in 2, 4, 6, 8, or 0, then I could divide that number by 2, and that will tell me how many of that fraction is equal to 1/2. Okay, so look at 6. When I have 6, if I divide 6 by 2, I get 3. So therefore, 3/6 is equivalent to 1/2. When I have fourths, if I take the 4 and I divide the denominator of 4 by 2, I get 2. So 2/4 is equivalent to 1/2. Now let's apply that same understanding to these fractions. So I have 14ths. How many 14ths are going to be equivalent to 1/2? Well, I'm simply thinking of 14 divided by 2, which equals 7. Therefore, 7/14 is the same thing as 1/2. 24ths, I'm thinking 24 divided by 2 equals, that equals 12. So 12/24 would be equal to 1/2. 18ths, what's half of 18? What is 18 divided by 2? Okay, that is 9. So I'd put 9/18. Okay? Let's see if, I'm going to give you a moment to see if you can figure out the 30ths and the hundredths. All right, hopefully we got 15 30ths and then 50 hundredths. So now let's put this in action. Let's see what this looks like in an actual problem, and then we'll be able to see how this works. So in our first example, a family hiked the same mountain trail. Evie and her father hiked 5/12 of the trail before they stopped for lunch. Jill and her mother hiked 9/10 of the trail before they stopped for lunch. Who hiked farther before lunch? So what we want to do is we want to take both of those fractions, 5/12 and 9/10, and we want to think about where it would be on the number line. Okay, is it going to be less than 1/2, or is it going to be greater than 1/2? Is it closer to 0? Is it closer to 1? So we're going to compare them first to 1/2. Now I'm thinking of the 12ths, and how many 12ths is going to be equivalent to 1/2? Well, we see on our number line 6/12 is going to be equivalent to 1/2. So where would 5/12 be? 5/12 would be right here, and I can shade in 5 of these. 1, 2, 3, 4, 5. Okay, and so I can tell just by looking at this that 5/12 is actually less than 1/2. Okay, so I'm going to write less, and you see I have my symbol. Now I'm going to think about 9/10. These have different denominators. 9/10 and 5/12 have different denominators, but I'm going to now compare 9/10 to 1/2. So now I'm thinking 9/10. Well, if I look at tenths, half of 10 is 5. 10 divided by 2 is 5. So 5/10 is equal to 1/2. But I have 9/10, so I have like more than that. So 9/10 is over here, and I can shade in 9 of my tenths. And even from looking at this model, we can tell that 9/10 is definitely larger than 1/2. Okay, and it's, I'm going to write this, so it's greater than. And so because 5/12 is less than 1/2, but 9/10 is greater than 1/2, I can say that 5/12 is less than 9/10. So the folks that hiked 9/10 of the trail hiked farther, and that was Jill and her mother. Okay. Let me give you a moment to jot that down. All right, so let's look at this next one. We're comparing 2/5 and 1/8. Now look at our number line. This is really fun. We have the fifths on the left and we have the eighths on the right. What do we notice about the fifths? Well, look. 1/2 is actually in between 2/5 and 3/5. And that's because 5, the denominator of 5, is an odd number. So there's not like 1/5, a particular fifth that is the halfway point. Okay, but we know it's in between. So I'm going to put my dot at 2/5, and I can shade in 2 of these fifths. And I can see that 2/5 is actually less than 1/2. Okay? Now I'm going to go look at my eighths. I'm comparing it to 1/8. Can shade in one of my little squares and I can put my dot right there. Now, what we may also know is in this example, 1/8 is also less than 1/2. Now this is one of those times when we actually could look at another benchmark because we see both of them are less than 1/2. Now I have to think of what else can I say to reason why one of these fractions would be larger than the other. Well, when I think about 1/8, I know it's really close to 0 because it's just 1/8 away from 0. Okay? And look at how far it is from 1/2. It's 3/8 away from 1/2. Okay, so 1/8 would be really close to 0. Now if I think about 2/5, it's not only 1/5 away from 0, but it's 2/5 away from 0. And even if I thought about 1/5, 1/5 would be a larger chunk than 1/8. Because with 1/5 you're just sharing it with 5 people versus 1/8 you're sharing it with 8 people, so they get less. Now 2/5 is also closer to 1/2 than it would be to 0. So because 2/5 is going to be closer to 1/2 than it's going to be to 0, we can then say that 2/5 is greater than 1/8. So go ahead and jot that down, and just remember, when we're comparing fractions to benchmarks, we might compare them to 0, we might compare them to 1/2, or even 1/2. Alright, in this next problem, we are figuring out how many sixths are equivalent to 1/2. Remember, I just take my denominator of 6 and I divide it by 2, and that equals 3. Therefore, 3/6 is equivalent to 1/2. Okay, question number 2. How can you compare 7/10 and 1/2 without using a model? Well, I'm putting our number line on here. So I have 0, I have 1/2, and somewhere in the middle I have 1/2. Well, if I think about the tenths, I want to think about how many how many tenths is equal to 1/2. Well, 10 divided by 2 equals 5. Therefore, 5/10 equals 1/2. And we know because there's more, there's 7/10, 7/10 has to be greater than 1/2. 7/10 is going to be somewhere over here on the number line. Okay, so I know that because 5/10 equals 1/2, therefore 7/10 has to be greater than 1/2, just because 7/10 is greater than 5/10. So go ahead and jot that down. And I'm fine if you explain it with numbers as I have, or you can explain it with words. I'll give you a few seconds to do that. All right, so we're going to think about these next few problems. And these next few problems are very similar to the ones that we've already done. So I'm just going to be thinking about a number line for each of these problems, so that will help me just think about what's closer to 1/2 and what's closer to 1/2 or even 0. So I have 1/2 over here. All right, so thinking about this first problem, number 3, 8/10 and 3/8. So I'm thinking that 1/2 of 8/10 is the same, 1/2 of the tenths, 10 divided by 2, would be 5. So 5/10, or thinking about the eighths, half of 8 is 4, so 4/8. So 4/8 and 5/10 are equivalent to 1/2. So now I'm talking about 8/10. That has to be greater than 1/2. And then 3/8, well, 3/8 is less than 4/8. So that has to be less than 1/2. So I can just put those right there. Therefore, 8/10 has to be greater than 3/8. Okay, the next one. I have 1/3 and 7/12. Okay, thinking about 1/2. 1/2 is gonna be between 1/3 and 2/3. Okay, and it's going to be 6/12. Okay. So now that I see where the halfway points would be with the thirds and the twelfths, I can now put these on my little number line. So 7/12 is going to be greater than 1/2, and then 1/3 is going to be less than 1/2. Because again, remember, the halfway point is somewhere between 1/3 and 2/3, so it'd be on the left side. So now looking at this, I can tell that 7/12 is greater than 1/3. So to fill in this bubble, 1/3 is less than 7/12. All right, let's look at the next one. Now I'm thinking of the halfway point of the sixth. Okay? So 6 divided by 2 equals 3. So the halfway point is going to be 3/6, and then for the eighths, half of 8 is 4, because 8 divided by 2 equals 4. So 4/8 will be that halfway point. So now that I've understood where 1/2 would be, now I can compare 2/6. Well, 2/6 is less than 3/6, so 2/6 would be somewhere to the left of 1/2, and then 7/8. Ooh, that's much greater than 4/8. So that is in fact going to be greater than 1/2. And it's actually really close to 1. Alright, so jot that down. For number 6, we're comparing 3/4 and 1/2. Now, let's think about our halfway point for the fourths. 4 divided by 2 equals 2, so therefore 2/4 is the same thing as 1/2. So now I'm comparing 3/4 and 1/2. Well, 1/2 is already on the number line for us, and then 3/4 is going to be greater than 1/2 because 3/4 is greater than 2/4. Alright, ooh, look at this one. I don't even really have to use my number line for this one because when I get to number 7, I see 6/6, and I know that is the same thing as 1 whole. Then I have 1/3. Well, 1/3 is less than a whole, okay, because it's a fraction. Okay, that would be even closer to 0. So I can just look at that and tell that 6/6 is greater than 1/3 because, again, 6/6 is equivalent to 1 whole. And if you have 1/3, you don't have a whole. Alright, let's look at number 8. Now with number 8, I have 1/6. I'm thinking about how many 6 does it take to make a whole? Well, it takes 6 of them. If I have only 1, that is going to be really close to 0. So 1/6 is going to be over here. And then 4/5. I know that 4/5 is just 1/5 away from 1 whole. So that's going to be really close to 1 whole, so I'll put 4/5 right over here. Now I was just able to think about the fact that both of those was 1 away from the 0 or 1 away from 1 whole. Okay, so that helped me see why 4/5 is greater than 1/6. Go ahead and jot that down. Now we're going to look at these. In this section, we have to make the statements true. So we're given 2/4, and remember 2/4, that's the same thing as 1/2. So 1/2 is greater than some number of eighths. Now I'm thinking, how many eighths are equal to 1/2? Well, 4/8 are equal to 1/2, so my numerator is going to have to be smaller than 4. I can put a 3 there, a 2 there, or a 1 there. I'll just put a 3. Alright, in number 10, we're given 5/10. Well, what do we know about 5/10? That is also 1/2. Okay, because 10 divided by 2 is 5. So now that amount, 1/2, is less than some number of eighths. Well, we already established that 4/8 equals 1/2. So now I need something greater than 4. Okay, so my box has to be greater than 4. So I can put 5/8, 6/8, 7/8, 8/8. I'm just going to do 6. Okay, in our next problem, we have 3/6 is greater than something. So 3/6, that is in fact 1/2 because 6 divided by 2 equals 3. So now 1/2 is going to be greater than some number of twelfths. So I'm going to divide 12 by 2. 12 divided by 2 equals 6. So 6/12 equals 1/2. So I have to have less than a 6 because look, it's telling me that 3/6, which equals 1/2, is greater than some number of twelfths. So I'm just going to go with 4. But I could do 0, 1, 2, 3, 4, 5. And maybe we don't want to do 0 because that just represents nothing. Okay? But 1 through 5 would work in that box. All right, I'm going to give you a moment to think about number 12. Oh, but don't forget 2/8. Even if you made that an equivalent fraction, you can get 1/4. Or you could think about 2/8 as just being less than a half. All right, for this one, I would have said anything over 4 would be a good numerator for this. Some of you may have just wanted to put 5 because 2/8 is less than 1/2, and then 5/10 is the same thing as 1/2. Okay, but anything 4 or greater would be great with what we've been talking about. Let's look at number 15. Some monkeys live high up in trees. 2 monkeys are climbing a tree. One monkey climbed up 5/6 of the tree. The other monkey climbed up 7/8 of the tree. Which statement about 5/6 and 7/8 is true? Now, in this problem, I can plot 5/6 and I can plot 7/8. Look at this piece that whoopsie, I'm not shading that part. Look at the part that I'm going to now shade. And then when I do 5/6, look at the part I'm going to shade here. Now this is one of those times that if I tried to compare to 1/2, I would say both of these were greater than 1/2. This is when I'm going to think about how far away from the, 1/2 are they. So when I look at 7/8, 7/8 is 1/8 away from 1/2, and then with 5/6, it is 1/6 away. Now look at the difference in the size pieces. I'm going to shade the difference in blue. Here's the 1/6 piece, and then here's the 1/8 piece. This is one of those times when if I'm looking at 2 fractions that are just 1 unit fraction away from 1/2, I want to take the one with the larger denominator as the greater fraction because it's a smaller piece away from 1/2. I can look at this 1/8 piece and see that it's smaller than the 1/6 piece. So 7/8 is going to be greater than 5/6. Or I can write it the other way. 5/6 is less than 7/8. So that's the answer choice I'm looking for, and it looks like that is what they give us with C. All right, boys and girls, I hope this homework made sense, and see you soon. Just to recap our video, today we were comparing fractions to benchmarks. So we have 0 as a benchmark fraction, 1/2 as a benchmark fraction, and 1/2 was a benchmark fraction. You could compare fractions to either of those. And when we did this, we didn't have to do a lot of math on paper. We were just using our reasoning. and our understanding of what fractions are and what they represent to be able to compare various fractions. I hope you enjoyed, and again, till next time, take care.